Hi, everyone. My name is Malte. These were the nested loops who performed last year at JSConf EU. You should check out the video. It's amazing. So many JavaScript fonts in 3 minutes of music. Yeah. By the way, I'm crime force in the internet. I don't really want to go into why that's the case. And there's another important fact about me. I used to build very large JavaScript applications. I don't actually do that anymore. So I thought it was like a good kind of time to give a bit of a retrospective and share what I learned. Yesterday, I was having a beer, and I was asked, like, hey, Malte, so what actually gives you the right authority to talk about this topic? And I was actually going to talk about it anyway, because I think it's a bit on topic. Usually, I think talking about yourself is a bit weird. So I built this JavaScript framework at Google, and it's used by Photos, Sites, Plus, Drive, Play, and the search engine, and like all these projects, right? So I guess some of them are pretty large. You might have used a few of them. And this JavaScript framework is not open source, which is sad, I guess, but I think there's some relevant things to be learned. And the reason why it's not open source is because it kind of came out at the same time as React, and I was like, do we really need another JavaScript framework? Like Google has a few of those, right? There's like Angular and Polymer, and I just thought it would confuse people. And so I thought, it's like, we'll just keep it to ourselves. But I don't think that's actually all that's not what this talk is about anyway, so I just have some stuff, and I think it's generally applicable. So let's talk about very large applications. What do they have in common? So certainly that you might have a lot of developers, right? So it might be like a few dozen or so, and so because there's now humans have feelings and have problems, and you have to factor that in. And even if your team is not as big, maybe you're working on that thing for a while, and maybe you're not actually the first person working on this. You might not have all the context. There might be stuff that you don't really understand. There might be people now on your team that don't understand everything that's in that application. So that's kind of what we have to think about when we want to build these very large applications that have maybe different properties from a smaller one. And another thing I wanted to do here is to give that a bit of a context in terms of everyone's careers. So I think many of us here in the room would maybe consider themselves a senior engineer, or we're not quite there yet, but we want to become one. And I think that's what that means is, as a senior engineer, I kind of think that I would be able to almost solve every problem that someone throws at me, right? I kind of know my tools, I kind of know my domain, and I can do things. And the other important part of that job is that I make the junior engineers on my team be senior engineers. But what happens is that at some point we wonder, like, what might be the next step? We've reached that seniority stage. What is the next thing we're going to do? And so for some of us, the answer might be management, but I don't think that should be the answer for everyone, because not everyone should be a manager, right? Like, some of us are really great engineers, and why don't we do that for the rest of our lives? So I want to propose a way to kind of level up a bit above that senior level. So the way I would talk about myself as a senior engineer is that I say, like, I know how I would solve a problem, right? And because I know how I would solve it, I could also teach someone else how to solve the problem. And so my theory is that the next level is that I can say about myself, I know how others would solve the problem. Let's make this a bit more concrete. So you make that sentence, I can anticipate how the API choices that I'm making or the abstractions that I'm introducing in a project, how they impact the way other people would solve a problem. I think this is a fundamentally powerful concept that allows me to reason about how the choices I'm making in software design, how they impact the application. And I would also call this an application of empathy, right? So you're thinking with other software engineers, and you're thinking about how what you do and the APIs that you're giving them, how they impact how they write software, right? Luckily, this is empathy on easy mode, because empathy generally is hard, and this is still very hard, but at least the people that you're having empathy with, there are also other software developers, or other software engineers, and so while they might be very different from you, they at least have in common that they, building software, and I think this is something you can get quite good at. All right, so thinking about these topics, there's one very important term that I want to talk about, which is the programming model. So, which is the word that I'm going to use a lot, which means, like, given a set of APIs or a set of libraries or a set of frameworks, set of tools, how do people write software in that context? And so my talk is really about how subtle changes in APIs and so forth, how they impact the programming model. I want to give a few examples about things that impact the programming model, right? So let's say you have your Angular project and you're saying, like, no, I'm going to port this to React. That is obviously going to change how people write software, right? But then you're like, 60 kilobyte for like this dumb diffing that seems unreasonable. Let's switch to Preact. And that's an API compatible thing. It's not going to change the way people write software just because you make that choice. Maybe then you're saying, like, oh, this is really complex. I should have like something orchestrating how my application works. I'm going to introduce Redux. That is going to change how people write software. You're then getting this requirement. We are needing a date picker, and you're going to NPM. You search for date picker. There's 500 results. You pick one. Doesn't really matter which one you pick. It will not change how you write software. But having NPM at your fingertips, this vast collection of modules, having that and being able to use it in your application, it does change how you write software. Cool. Yeah. So these are just a few examples about like things how you can impact the way people write software. Now I want to talk about one aspect that all large JavaScript applications have in common when you deliver them to users, which is that eventually they will get so big that you don't want to like deliver them all at once. And for this, we've kind of all introduced this technique called code splitting. What code splitting means is that you define a set of bundles for your application. So you're saying, like, some users use this, some users use that. Let's put like a bundle together, and I'm only going to load that bundle if the function of the application that the user is actually using is being executed. And that's something that every one of us can do. Like many things, it was invented by Closure Compiler, at least in the JavaScript world. But I think the most popular way of doing code splitting is with Webpack. And if you're using, for example, Rollup.js, which is super awesome, they just recently, a few weeks ago, added support for this. So definitely something y'all should do. But there are some things to think about when you introduce this to an application, because it does have impact on the programming model. You have things that used to be sync that now become async. So without code splitting, your application is nice and simple. It's this one big thing. It starts up, and then it's stable, and you can assume stuff about it. You can reason about it. You don't have to wait for stuff. With code splitting, you might sometimes say, oh, I need that bundle, so you now need to go to the network, and you have to factor in that this can happen, and so your application becomes more complex. Also, we have humans entering the field, because code splitting requires you to like define bundles, and it requires you to think about when to load them. So these humans, the engineers on your team, they have to now make decisions. What is going into which bundle and when to load that bundle, right? And every time you have a human involved, that definitely impacts the programming model, because now they have to think about it. Now, there is one very established way that solves the problem, that gets the human kind of out of this mess when doing code splitting, which is called route-based code splitting. And that is if you don't do it yet, that's probably the way how you should do it as a first cut. So routes are like the baseline URL structures of your application. So for example, you might have all your product pages on /product/ and then some ID, and you have your category pages somewhere else, right? And so your router in your application now understands there's code splitting, and whenever you go to a route, the router loads the code, and then within that route, you can forget about code splitting existing, right? Now you're back to the programming model that was almost the same as if you had just one big bundle for everything, right? So it's a really nice way to do this, and definitely a good first step. However, the talk title is designing very large JavaScript applications, and they're so large that sometimes a single route bundle might not, be feasible anymore, because those routes itself get very big. I actually have a good example for an application that's big enough. So I was like figuring out how to be a public speaker coming up to this talk. And I got this like nice list of blue links, right? And you could totally envision this page to be like super well, fitted for route-based code splitting. It's like /search/, and there's this list of stuff, and it's not very complicated. But then I was like kind of wondering what the weather was, because California kind of had a bit of a cold one. And so I was searching for weather, and suddenly there was this completely different module, right? And so this seemingly simple route of /search is more complicated than we thought. And then I was getting invited to this conference, super exciting, and I was checking out how much US dollars are in $1 Australian, and there's this complex currency converter. And so again, I think obviously there's like 1,000 special ones of these, right? And so it's infeasible to say we're going to put all of them in one bundle, because then that bundle is going to be like a megabyte, and people are going to be unhappy. So we can't do it that way. We have to come up with a different way of doing it. Now, route-based code splitting was nice because at the very coarse grain level of your application, at the very highest level, you made that split. Everything under it could ignore it. Because I like simple stuff. If you don't do the super coarse one, how about the super fine-grained version, right? Let's think about what would happen if we lazy loaded every single component of your website. That seems really nice from a efficiency point of view when you only think about bandwidth, right? It might be like super bad from other point of views like latency, but it is a nice way of doing it and one to consider. But let's imagine, for example, your application uses React. In React, components statically depend on their children, right? And that means that if you stop doing that because you start lazy loading your children, then it changes your program model and things stop being so nice. So let's say you have a currency converter component that you want to put on your search page. You import it, right? That's like the normal way of doing it in ES6, and that's pretty nice. But if you want to lazy load it, you get code like this, where you use dynamic import, which is a new fancy thing to lazy load ES6 modules, and you wrap it into some loadable component. And there's probably 500 million different ways to do this, and I'm certainly not a React programmer or even anywhere to expert, but it's definitely going to change how you write the application, and that's no longer as nice because stuff, is more complicated. Something that was static now is dynamic. So that's another red flag for the programming model changing. You have to suddenly wonder who decides what to lazy load when, because that's going to impact the latency of your application. The human is there, and they're like, there's static import, there's dynamic import. When do I use which? It's also really bad if you do it wrong, because one static import is going to make everything be together again, and you don't really get any benefits from dynamic loading. So that's really complicated, and it's going to go wrong when you have a lot of engineers over long periods of time. Now I'm going to talk about how Google actually does it, and what one way is to achieve a good programming model with good performance and hopefully good results. So what we're doing is we take our component, but we split it by rendering logic, so the way we render it, and the logic of, for example, on the currency converter, what happens when you press the button and you get, USD to Australian dollars. So we have these two things instead of one thing, and then we only load the logic of a page when we actually rendered the component. And that, again, is a very simple model, because now we can just server-side render a page, and then whatever we kind of actually rendered, because you searched for weather and there was a weather module, then that rendering of the weather module triggers the client to load the code. And again, that kind of puts the human out of the conversation. We get that Australian dollar answer, and we have a very simple page. Now, that might seem nice, but it does have some trade-offs, right? So if you know how server-side rendering typically works with frameworks like React or Vue.js or so forth, what they do is a process called hydration. The way hydration works is you server-side render something, and then on the client, you render it again, which means you have to load the code to render something that's already on the page, which is incredibly wasteful, both in terms of loading that code and in terms of executing it, right? So it's a bunch of wasted bandwidth, it's a bunch of wasted CPU, but it's really nice because you can ignore on the client side that the server-side rendered something, right? And that is very nice. And so if you design this very large application, you have to think about, do I want to take that super fast route, but it's more complex, or am I okay with the hydration approach, which is less efficient, but it's so nice for programmers, right? And so you will have to make this decision. Nobody can help you with that. Cool. My next topic is my favorite problem in computer science, which is not naming things, although I probably gave this a bad name, and it's not off by 1 error. It's the 2017 holiday special problem. Who here has ever written some code, and now it's no longer needed, but it's still on your code base? Right? So maybe there was a 2017 holiday party special or something like that, right? So this happens. I think CSS is particularly famous for it. You have this one big CSS file, and there's a selector in there, but who really knows if that still matches anything in your application, right? So you kind of just keep it there. And so I think the CSS community is at the forefront of a revolution because they realized this is a problem, and they created solutions like CSS and JS, right? We have a single file component, the 2017 holiday special component, and you say, okay, it's not 2017 anymore. We can delete this one component, and then everything is gone, and it's very simple. So very easy to delete code. So I think this is a very big idea, and it should be applied to more than just CSS. So I want to give a few examples of this general idea that you want to avoid central configuration of your application at all costs, because central configuration, like having a central CSS file, makes it very hard to delete code. So I was talking before about routes in your application. So many applications will have a file like routes.js, which is all your routes, and then those routes map themselves to some root component, right? And that's an example of central configuration. It's something that you do not want in a large application, because now, some engineer says, do I still need that root component? They're like, I need to update that file, but that's kind of owned by some other team or something like that. I'm too scared to do it, and maybe I'm going to do that tomorrow, or maybe I don't do it at all, right? And so this file is more it's addition only. People don't tend to get rid of stuff. Another example of this anti-pattern is the webpack config.js, where you have this one thing that's assumed to build your entire application. And that might go fine for a while, but eventually, needing to know about every aspect of what some other team did somewhere, right? That just doesn't scale. So again, I think we need a pattern that has to emerge how to decentralize configure stuff that we want to build. It's not only bad examples, there's good examples. So for example, package.json, which is used by NPM, right? Each package says, I have these dependencies, this is how you run me, this is how you build me, and obviously there's not this one giant configuration file for all of NPM, because that would not work, right? Would you imagine having 100,000 modules and you would have to edit this one file? Would definitely give you a lot of merge conflicts in Git, right? And so, sure, NPM is very big, but I would argue that many of our applications, while they're not as big as NPM, they get big enough that we have to worry about the same stuff, and we have to kind of adopt the same patterns. So I don't really have all the solutions, but I think this, this idea that CSS and JS brought to the table is going to come to other aspects of how we build applications. More abstractly, I would describe this idea that we take responsibility for how our application is designed in the abstract, how it's organized, as taking responsibility of shaping the dependency tree of our application. And with dependency, I mean that's very abstract. It could be ES6 module dependencies, it could be data dependency, it could be service dependencies. There's many ways to have dependencies. So obviously, we all have super complicated applications, but I'm going to have a very simple one. It has only 4 components. There's a router that kind of knows how to go from one aspect of your application to the next, and it has a few root components, A, B, and C. Now, as I mentioned before, this has the central import problem, right? Because the router now has to import all the root components, and if you want to delete one of them, you have to go to the router, you have to delete the import, you have to delete the route, and so forth. And that eventually ends you with the holiday special 2017 problem. Wow, yeah, so we have at Google come up with a solution for this that I want to introduce to you, which I don't think we've ever talked about, but it's kind of cool. We invented a new concept. It's called enhance, and it's something you use instead of import. in fact, it's the opposite of import. It is a reverse dependency. So if you enhance a module, you make that module have a dependency on you, which seems kind of cool. So looking at the dependency graph, what happens is that they're still the same components, but the arrows now point in the opposite direction, right? So instead of the router importing the root components announce themselves using enhance to the router. The root component A says, hey, router, here I am. Please have a dependency on me, instead of the opposite array, right? And that now means that I can just get rid of the root component A by deleting the file, and because it no longer enhances the router, that's the only operation I have to do to delete this component. And that's really nice. If it wasn't for the humans to now have to think about, I have import, I have enhance, which one do I use under which circumstances, right? And so they suffer from this. And I think this is a particularly bad case of this, because imagine just how dangerous it is that you as a programmer get the power to make everyone else, every file in the system have a dependency on you. It's easy to imagine that this leads to really bad situations. So at Google, we decided it's a nice idea, but we make it illegal. No one gets to use it. One exception, which is generated code. It's a really good fit for generated code, actually. And it solves some of the problems that generated code has, which is also really nice. So with generated code, sometimes you have to import a generated file that you can't even see. You have to guess its name. It's really unpleasant. If that generated file is just there in the shadows and it enhances some central entity, then you don't have these problems, right? You never have to know about this file. It just magically enhances the central registry. And so that works really well. Let's take a look at a concrete example. So we have our single file component here, and we run a code generator from it, and we kind of extract this little route definition file. For example, maybe use some static declaration in your single file component. We parse that out using an awesome Harry Potter AST, and then we have that route file, right? And that route file just says, hey, router, here I am. Please enhance me, and that's how it works. And then obviously, you can use this pattern for all kinds of other things. Maybe you're using GraphQL or some other thing like that, and you're saying, hey, my data dependency, the router should know about it, and you're doing the same pattern. Maybe you have some services, whatever, right? Whatever fancy words you have in computer science. So you can use this pattern, and I think it works really well. It's really powerful, and I think it has a good future. All right. Fortunately, this is not everything we need to know about it. There's a second favorite problem in computer science, which I call the base bundle pile of trash. So the base bundle in your graph of bundles of your application, it's the one bundle that whatever you do, whatever the user is doing, you will always load this one bundle. And so it's particularly important because if it's big, then everything you'll do is big, right? If it's really small, then you can have really small dependent bundles, right? Little anecdote, I at some point joined the Google+ JavaScript infrastructure team, and I found out that the base bundle had 800 kilobytes of JavaScript. And so my warning to you is, if you want to be more successful in Google+, don't have 800 kilobytes of JavaScript in your base bundle. And unfortunately, this is very easy, right, to get to a bad state. I'm going to show you a few examples. So again, your base bundle, it needs to depend on the routes, because you always want to know when you go from A to B, what is the route for B, right? So it has to be there. But what you really don't want is any form of UI, because depending on where the user comes in, there might be different UI. So you really don't want that UI to be there, right? And so, no, the date picker, it definitely should not be in your base bundle, right? The checkout flow should not be in your base bundle. And so how do we prevent that, right? Unfortunately, imports are very fragile. You might innocently import that cool util package, right? Because it has a function to make random numbers. And now someone says, I would need a utility for self-driving cars. And suddenly you are import the, machine learning algorithm for self-driving cars in your base bundle. These can happen really easily, and because imports are transitive, things can pile up into that pile of trash. The solution we found for this that I think is also a very powerful pattern are forbidden dependency tests. So forbidden dependency tests are a way to assert that, for example, your base bundle does not depend on any UI. Let's take a concrete example. So for example, in React, every component needs to inherit from React component. So if you want that your no UI at all can get in your base bundle, you simply add that one test saying, React component is not a transitive dependency of my base bundle, and it will just fail, right? So looking at the graph again, you just get a test failure when someone tries to add the date picker. And it's typically, like in that case, it's usually really easy to fix it right away because probably that person didn't actually want to put it there. It was just some weird transitive dependency. But if you're like 2 years in and it's been there for a while, it's typically super hard to get this stuff disentangled. So that test really helps you. All right. Ideally, though, you find like that most natural path, right? You want to get to a state whatever the engineers and your teams do, the most straightforward way to do something is the right way, right? So that they don't get off the path, that they naturally do the right things. And then, as I just showed with the forbidden dependency tests, just add a test. And I think this is also something that not many people feel empowered to do. So please feel empowered to add tests to your application that ensure the major invariant of your infrastructure, right? So tests are not only for, testing that your mass function does the right things, right? They're also for infrastructure and for the major design features of your application. So please do that. And try to avoid human judgment outside of the application domain, right? So if you work on an application, we have to understand the business part, but not every engineer in your organization can and will understand how code splitting works, and they don't need to do that, right? So try to introduce these things in your application in a way that it's completely fine, you can still work well without having that knowledge and all that complexity in your head. And then also really just make it easy to delete code. So my talk was called Designing Very Large JavaScript Application. Maybe the best advice I can give is that you should ideally not get to this very large state. The best way to not get there is that you delete stuff before it's too late. Cool. I want to then address just one more point, which is people sometimes say that having no abstractions at all is better than having the wrong abstraction, right? What this really means is that the cost of the wrong abstractions is very high, so be careful. I think this is sometimes misinterpreted. It does not mean that you should have no abstractions. Again, it just means that you have to be very careful. And so I think my main advice is to get good at making the right choices, right? And as I was saying at the start of the presentation, the way to get there is to think with your engineers on your team how they will use your APIs and how they will use your abstractions. You can get there with experience. It will take you a while. I have done this wrong most of the time, and I still do, but I think I'm still getting better. And so empathy and experience are the way how you can have the right abstractions in your application. Thank you very much.